Okay, my name is Ahmad Adumkoyum Azlan, and today I will present my FYP project, IT Suite, which is a secure organizational security platform. So, IT Suite brings together four usually treated as separated problems. Firstly, attendance monitoring. Second, encrypted file sharing. Third, credential vault. And lastly, security monitor. This is all integrated into one system. Okay, next. For the problem statement. So let's start with why this project exists. Most organizations today rely on digital systems for attendance, file sharing, and storing credentials. But a lot of these systems weren't built with enough security in mind. So there are three specific gaps I focus on. Firstly, attendance fraud. A login-only check-in system has no way to confirm if someone is actually present at the office. So fake GPS apps are easy to get, and they let an employee report a location, but they are not really there. Second, unsafe file sharing. So email and chat apps don't encrypt anything, and there's no way to confirm if file wasn't altered between sender and receiver. So third, exposed credentials. Password and API keys often sit in plain text somewhere with no audit who access them or when. And top of all three, there's usually no single dashboard that tries suspicious that will detect suspicious activity across all of them together. That's the gap IT Suite is built to close. Okay, next. So for the objective, this project focuses on three objectives. Firstly, to study the actual security vulnerabilities organizations face around attendance, file sharing, and credential. Second, to develop secure modules that address each of those gaps, built into one integrated platform rather than separate tools. Lastly, to test the system against the OWASP Top 10, which is industry standard list of the 10 most critical web application vulnerability category. Okay, next. System architecture. So here's how IT Suite is structured under the hood. It follows 6-layer architecture. At the top layer, there's user layer, the employee mobile interface, and the admin web dashboard. So below it, the front end modules: attendance, file manager, secure vault, and secure monitor. Underneath that sits the Flash backend. It handles the authentication and encryption, and also a dedicated security validation engine that does the GPS, BSSID, and integrity checks. Everything is backed by the MySQL database, and the system talks to external services like Google Maps API and email service for OTP delivery. The reason this is laid out in layers is so the security logic stays separate from the rest of the backend. It made testing and maintaining each piece a lot easier. So next. Okay, so the modules. So in practice, that architecture becomes 4 modules. Firstly, attendance. Checks GPS location against geofence, verifies the Wi-Fi network, and detect if the user using mock GPS and rooted devices. So next, file manager encrypts file automatically with AES 256 GCM, then checks integrity with SHA 256 and protects download with bcrypt hash passcodes. And next, secure vault. So this vault stores credentials with the same AES 256 GCM encryption, but requires a PI OTP or OTP, one-time password, and rule-based access before anything is revealed. And lastly, security monitor. So this pulls events from all three modules in real time and runs 4 detection rules to flag suspicious activities. So the secure monitor just record every activity on the modules. So next, we will continue with live demonstration. So next is testing result. To make sure all of this actually works, I ran 28 test cases across 3 categories. So 14 functional tests covering attendance, files, and the vault and lastly the monitor. 10 security tests covering the full OWASP top 10. 8 integration tests, making sure the 4 module genuinely works together, not just on their own. And all 28 tests pass. Okay, next, for the OWASP top 10 breakdown, I want to go a little bit deeper on the security testing specifically, since that's the part most directly tied to my third objective. So each row is one OWASP category mapped to the exact test case I ran against it. For example, the SO1 tested broken access control. I tried to open the admin only secure vault page directly through the URL as an employee account, and the system currently blocked it on the server side. So from the employee side, we cannot access the secure vault. So next, SO2 tested the cryptographic failures. I went into the database directly and checked the stored files and vault records. No plain text anywhere, just AES 256 GCM ciphertext. And then like the SO7 authentication failures. I ran brute force login attempt, and the system currently correctly logged and flagged the repeated failures. All 10 categories pass, with the 3 I rated high severity: broken access control, cryptographic failures, and authentication failures, treated as priority areas throughout development, since failing any of those 3 would expose the most sensitive part of the system directly. So this is the database. So I also want to be clear with this result aren't just claim I'm making, they are backed by the actual data. So as you can see here, this is the raw attendance log table pulled directly from the database. You can see a real entry here, flag mock GPS detected. So that's an actual spoof check-in attempt that the system caught and logged, not just something shown correctly in the interface. I did this kind of direct database verification across several modules, checking that what the dashboard actually matches what's stored underneath. So next is limitation and future work. So I want to be upfront about the where IT suite currently stands. Limitations. It's been tested within a single organization on a local server rather than public production, big company production, and the file manager currently only accept fixed list of file types. So for future work, I like to extend the security monitor with machine learning, if possible, based on anomaly detection and biometric verification to the attendance module, and generalize the system to support multiple office branches instead of just one. But the core idea holds: attendance file security, attendance file security and credential protection can work as one connected system, not 3 separate tools. So thank you. That's all from me.